And he found that if he wins, then he loses, because he would be killing his nears and dears. His acharya, he would be killing Dronacharya, he will be killing his cousins, and there will be so many widows. So, and at the same time, he felt that if he loses, so what's the point of fighting the war? So he was confused that what should I do? What's the point of fighting the war? I'm a loser either way. So he's asking Krishna that, so even at the battlefield, he's asking questions, right? And he would ask same questions again and again. And Krishna would reply all those questions. So one thing I find that in India, or actually all over the world, that in the classroom, students do not ask questions. You have to ask questions, whatever in your mind. Sometimes you feel that, oh, I would be looking stupid if I had this question. But you may find that when you ask a question, everybody has the same question in their mind, and they feel good about it. So in the classroom, if you are sitting, you are entertaining a class, try to sit on the front seat, ask some questions, make yourself visible. And that's how it is, because if the teacher has to single out somebody, right? Single out a leader, right? Ask a leader who asks questions, who has a probing mind. So you should have a probing mind. You should be asking questions, right? Also remember that in India, all the Upanishads, Bhagavad Gita, they are Q&A, question and answer. There is no sermons that a teacher is teaching you. A student would ask questions and teacher would reply. So that should be the case, right? You should not allow, you are in a private school, you are paying good sum of money. And so if you have some question, you do not like something, or you do not understand something, ask questions, provide some feedback, because the teachers exist there because of you. And a mentor listens to you and gives advice and objective feedback with your interest at heart, right? Help you at the time of distress. Identifies your internal strengths, weaknesses, opportunities, and threats, right? In organization, teaches you corporate culture and valuable career moves. So you as students, discuss whatever in your life with your parents, right? If you have older brother, older sister, or cousins, whosoever, they could be your mentor, right? Discuss, and they can provide you very valuable input. If you have feasting, somebody is trying to blackmail you, somebody is trying to take advantage of you, discuss with somebody, have somebody who can confide in you, can discreetly listen to you, keep your information confidential, extremely important. And it's a two-way street. We get advice. The mentor gets the chance to pass on the wisdom, right? It's a reverse mentoring today, right? And if you don't have good mentor, use IEEE resources for mentorship, like you invited me because of the IEEE connection, right? You could ask every great achiever in the world, every great achiever, right? They are inspired by a great mentor. So the goal of this slide to tell you that first thing, if you want to succeed in your career, you should have a mentor, and you should be able to ask questions. If you are being interviewed, research about that organization and ask some intelligent questions. Okay. And second second slide is equally important. Here is the commander-in-chief of Shri Ram's army, right? And so he had a curse. He could do anything, right? He could fly, he could cross the story is like this, that he could cross the entire ocean in one step, right? But he had a curse. And his curse was that he would not know his strength. He would forget. He used to forget. He had a curse that he will not know his strength, so that he could not misuse of his power. As a child, he was very mischievous. He used to create trouble, for others. So a rishi, gave him a curse. So that kind of curse we all have. We do not know our strength. We do not know what we can achieve, how far we can go, right? We only think that, hey, how do I know? What can I do about it? I'm just in a small school, I can get a job nearby and that's good enough. So when you have a good mentor, would allow you, to help you to realize your hidden strength. We all have hidden strength. But my dream was only to become like an LDC, UDC. And I applied for some of the jobs and I was not successful. They will not even invite me for an interview because they felt that I was too qualified. And then I go to my mentor and they said, hey, I'm stupid. Why am I trying there? And they opened the door for me that they showed me, hey, I could do this, I could do that, I could do that. And when I came out of my cage, and I found that the whole world was open to me, right? And so a lot of people helped me in my life. They would tell me, hey, I could do this, this is an opportunity. And by giving you this talk, I'm giving back, right? Sharing with you that you have unlimited strength, right? You allow others to find your hidden strength, and you inspire others to find theirs, right? So when you have, in the class, you have good team spirit, right? So in the team always wins because each team member help others. So this is what you should keep in mind if you want to make a career. Doesn't matter in what field, in whether you are an administrative service, you are in defense, you are a soldier, or you are an engineer, whatever you do, you do your excel. And remember, go an extra mile. Hanuman did not know, what kind of herbal he was supposed to bring. He brought the whole mountain. So oftentimes, people go all the way, but they don't go the last mile, right? They leave the last mile. And what happens that last mile is very important. So there is a game there we used to play in my childhood called, is shooting and ladder, that you go, and if you reach the 98, you have to get number 2 to win the game. But if you get 199, then you have a jumbo snake will bring you at the bottom. And that's what happened in our life. Most of the time, we are almost winning, but something happened at the last moment, we come at the bottom. But that's the part of life. You have to realize that, right? So go an extra mile and always be part of the solution and not the problem. If you have a problem, think about the solution. And so if you are making in school, if you have a problem with your faculty or with the system, think about how could it be done better, right? So then always complain only, when you have some suggestion. Because if you have suggestion which could be implemented, then your complaint would be registered and you would be, considered a hero. And you should go and get type. People don't like when people find excuses. Oh, I could not do this. My mother was sick. You will find a lot of people. They use their mother or grandmother or grandfather. Oh, my grandmother was sick, or 100 of times they make grandmother, die. Oh, there was a funeral of grandmother when grandmother died a long time ago. So those are not the kind of things you want to be. You want to be honest, truthful, and go and get type person, right? So at the same time, Mahatma Gandhi used to say that you be the change you want to see in the world, right? And President John F. Kennedy used to say, one person can make a difference and everyone should try. So keep that in mind. So today, there is no lifetime employment. You can take any job. You may find that you don't like the job, right? You have picked the wrong. It happens everywhere. Oftentimes, that a lot of divorce are taking place. You married somebody, though you were in your love marriage, you were in love affair, you marry somebody, and soon after that, you find that this is the wrong partner I have, and you end up divorce. Similarly, you take up a job and you find that this is not for you. You don't like the company, you don't like your boss, you don't like the work. So there is no lifetime employment today. What is important today that you should have lifetime employability, that if you lose your job today, you should be able to find another one. Or somebody should be approaching you that, hey, we would like to have you, right? So I mentioned that key part is that you find a mentor or mentors or IEEE resources you could use. And if you have a job, behave less like an employee and more like an entrepreneur, an owner. Dedicate yourself in creating, selling, and delivering values. View your employer like a customer. Invest heavily in your core skills and technology. So a communication skill is very important today, right? And these are the soft skills. Define your communication skills. Be self-managed and self-reliant. Work on winning projects. And teamwork is extremely important. If you work together, working on a project, then you may find that you have two people, one and one make 11. So think about that. So work together, right? And today, in digitization, the world has changed. Digitization, Uberization, disintermediation, globalization, outsourcing, merger, acquisition, restructuring. These are the facts, right? And you have companies like Bed and Breakfast. They don't own any hotel. but is one of the largest company. Uber does not own any taxi, but largest taxi company today, right? Amazon doesn't manufacture anything, but you can buy anything from them. So those are the kind of things, right, today. Now, use your IEEE resources. IEEE is a great resource, right, in this time, right? So think about that. These are very challenging and exciting times, right? Good jobs are disappearing, but new opportunities are emerging. Global competition, you have outsourcing, disruptive technologies. And despite the abundance of potential workers, companies have trouble in finding critical skill and top-performing talent. And this is the biggest complaint people have today, that they can't find the right people. They don't have the skill, and the birth rate has been falling in many developed countries. And people whosoever, they don't want to even study science, technology, engineering, math. They want to study other things. They want to go in banking, finance, insurance. They don't want to do science and engineering because it's very demanding profession, right? So take advantage of these opportunities. The whole world, because of this globalization, because of this digital world, you have access to everything, right? Like I'm talking to you from sitting in the US. So you can approach anyone, and the world is transparent, it's visible. You can figure it out who is doing what, and you can work for any company, for anyone, from anywhere, right? And be flexible and mobile for more opportunities and control your career. So the goal is, while you are a student, think about right now, you are at the right time. Decide what you want to do in life. And then find out who has value for it. And for that, you can use IEEE resources or other resources and approach those people and make them pay. That's what I have done in my life. I decided that I wanted to do PhD, but I wanted to do PhD abroad. So I figured it out that there is some foreign scholarships. I found there was a Commonwealth scholarship, offered in a number of countries. So I studied that part and I applied for one, and I went abroad in the United Kingdom and did PhD. So somebody paid for it. And similarly, I have been in research. So there are different kind of field today. One is called research, second called development, and third called manufacturing, right? These are the engineering areas. Of course, there are multiple other activities like sales people, marketing people, strategy management. So in a company, you may find that. See the structure. If your mother is working in any company, see what are the roles in the company, what are the kind of people they employ. But I'm talking about engineering. In engineering itself, there are three kinds of jobs. You have research, development, and manufacturing. And those three things, oftentimes we do not know. I do not know myself. If you are working for an industry, you feel that I'm working for an industry. But industry also has three different kinds of jobs: research, development, and manufacturing. And you have to figure it out what kind of person you are. If you are a kind of person that you don't care, you want to go 9 to 5, and you want to take orders, or you want to do your job and come back home and spend time with your family, then manufacturing is the kind of thing. In the manufacturing, once they have developed the process, all you have to do is maintenance, right? Go there, something gets broken, make sure that everything is working, everybody is doing the job. But in research, you have to come out with new ideas. You have to do other things. In development is more innovation, that you use the existing research base and based on that, build something new. That is a development, right? So you have to think about that. These are the kind of things that where you want to be, right? So I just giving you a high-level idea because the photonics has thousands of things, and you have to think about what is good for you. Now, what are the IEEE resources available to you? In this talk, I can't cover everything, but there are resources available there. You have IEEE Digital Library. As a student member, you have access to them. But there is a journal called Proceedings of IEEE. And Proceedings of IEEE has review article. Right, it's a review article, and it talks about emerging technologies. So you scan them. Every month, every issue, you should scan every one of them. What is emerging? What is happening in the world? You don't have to read the entire article. Read just the abstract or the conclusion, right? First page, the last page. And if you're more interested, then you can go in between. But your library may have access to this. If you don't have access, then ask your library to have an access to that. Then you may have a password to IEEE resources, and you should be able to get access. IEEE Spectrum is a monthly magazine, and that also review the emerging technologies and scan them. But if there are trade shows, you should always go to the trade shows. In the trade shows, you will meet the companies, the people, who you might be working one day. You see what are the new products out there, what is the feeling, what direction the world is going, right? And you may have in Trivandrum some exhibits, in Bangalore exhibits, and coaching exhibits. So, and there are magazines and journals of IEEE, 39 technical societies. So it doesn't have to be photonics, could be any field. As mentioned to you, photonics is enabling technologies. It is everywhere. You may find communication people use it, energy people use it everywhere. And invite speakers. Like, you like particular field, you like somebody's paper, invite that person to give a talk to you, right? If you feel that a paper, I like this area. And so the IEEE provide you a platform. This chapter provides you a platform. Suppose you have roast me to give a talk just like that. Probably I may not be inclined to do that because you are a IEEE chapter. So it is an honor to talk to you. So you have the IEEE local chapter events. Other chapters, maybe we have formed Prakash Bharati, and all other chapters, when they have event, they advertise it. So because of this virtual presentation, you can attend any talk anywhere, right? Not only in India, globally. So use Google and search engines. IEEE also has many tutorials and webinars, and you can take advantage of that. You find that you have a boring teacher, you don't like the teacher, you don't like this, that's a tutorial available. Now, IIT Delhi, actually, they had a conference this past weekend. They have opened a center in IIT Delhi. It's called Optical and Photonics Center. It's a national center, Optical and Photonics Center, and their website. And they have also put tutorials, learning resources. And those resources are starting from high school to engineering, means that lower level to higher level. So if you want to learn about photonics or something, you can go to the website, and they are done by prominent professors. So you can get access to those resources just sitting at your home. And IEEE has a special low rate for students, unemployed IEEE members, provide mentoring, and many other services. So join IEEE, and or a society, upgrade your membership, become a volunteer, like you are a volunteer invited me. And these are different societies, 39 societies. And so this also shows what are different fields. So photonics is one of them, but do not, and you are a photonics member, but that's good. But at the same time, you can't neglect everything because everything is so important, right? So you go through this and see you can do that. The Photonics Society itself is quite big. We have 150 chapters like yours globally, and India itself has 37 chapters. In last 1 year, we opened 10 chapters, and we provide grant up to 2,500 per chapter per project. So your institute is the largest beneficiary, right? This year alone, we have given 50,500 to various chapters in India, right? Our emphasis is women in photonics. So if you are a woman in photonics, you have better chances of getting the funding. Underrepresented minorities, multicultural outreach and globalization with target nations, Latin America, Africa, India, right? So these are the areas. So that's why in India today, receiving a lot of attention. And we are trying hard to bring STEM, science, technology, engineering, mathematics, into light. Now, this is very important. I'm going to tell you that STEM word has been changed to STEAM. STEAM, S-T-E-A-M. So they added A. So you already know science, technology, engineering, math. A is art. So they felt that art is as important as engineering. Why? You like for example, Apple iPhone. There is a lot of art in there, right? Anything you want to buy, it has some value, right? Status value. And you want to buy something, you feel good about it. You want to have a watch. The old watch do the same thing, tell you the time. Whether you buy a 100 rupees watch or you buy a $1 million watch, they do the same thing, right? Tell you the time. But there is something more to that, right? Ornamental values, right? So, and how does it look? How does it feel? And that is the art. So just being an engineer is not good enough. You have to appreciate art also, right? How to design a product, right? How does it look, the product? So, it doesn't should not have sharp corners. So this is what STEAM is important. But now STEAM also has been changed, called STREAM. They added one another word, R. STREAM. R stands for read and write. So a lot of engineers, they are very good, but they can't communicate properly. Or they can communicate very properly, they cannot write properly. If they have to write something they can say in one sentence, they would write one whole page. So the important thing is that full child growth. You cannot be just good in one area today. That's the challenge, because earlier, we were living in a pocket. What is happening outside us doesn't matter. In US, all you had to do, there were so many jobs, you had to compete with your neighbor or somebody for a job. But those jobs have gone to China now, so people have to now compete with everyone. So remember the word STREAM, STREAM. Science, technology, read, write, engineering, art and math. So in your school, when I was a student, I felt that, hey, why do I have to worry about art? Why do I have to worry about history? Why do I have to worry about geography? But everything is important now, right? In IEEE, we also provide a STEM kit, to teach geometrical optics, something you spend 4 months to study, but our kit, in 1 hour, you can teach geometrical optics. So Photonics Society has, many webinars, you can archive them. So use these resources, right? And there are many journals here. And you could go to the library, you may be getting some of them, or electronics library, and see that what is in there, what are the emerging fields appearing, right? So Photonics Society has a monthly chapter, a monthly newsletter, also a bi-monthly newsletter. And that also has a lot of resources, a lot of lectures, a lot of, invitation for for requesting funds. So as chapter, you should go through that too also, right? Now I'm coming back to career in photonics, right, particularly. So as I mentioned that India has this called, first of all, photonics is photon. It means that study of photons is photonics, right? The Hindi name of photonics is Prakash Shakti. Prakash means light. So a photon is the power of light, called Prakash Shakti. And these are the buzzwords, right? Sabka Vishwas and Atmanirbhar Bharat, Oftentimes when you want to get funding or you want to do something, you could use these buzzwords, people, it draws their attention. So we had a 1 month long meeting last October, and Indian diaspora, about 100 of scientists joined that. There were 19 different fields, and photonics was one of them. So they came out that these are the 4 great areas. Agri-tech means photonics for agriculture, smart farming, water management, soil health management. These are just some examples. And then you have infotech, like we are doing, optical communication. Through optical communication, we are talking, Internet of Things, artificial intelligence. And there is nanotech. In the nanotech, we have sensors, LED, renewable energy, socio-economic impact. And then in healthcare, biotech, cancer imaging, breath analyzer, biomedicals. So I was told that the role of photonics in healthcare. So these are the different, some areas, right? And they're funding, their money here. So India needs everything here, right? So these are the areas, and the growing there. Now in India had to invest because everything is done in China. But you think about what appeals you, which area appeals you, and for that you go to see the IEEE journals, go to Google search, and dig more into that. So these are the 4 areas, in great area, but because something is missing here called defense tech. Application of photonics in defense. So India today is the largest importer of the defense technologies, and the defense, they have to pay at least 10 times. I know when you want to, because the defense stuff is not allowed to be imported, right? So company who is selling you have to go through a lot of paperwork getting permission. So something a company sells for $1 in US will be selling for $10 in India. And now India is surrounded by enemies from everywhere. So photonics would play a big role in there, and many job opportunities. So think about that, wave particle duality. And you can extend that, and say the Lord is Sakar or Nirakar, So you can say that Lord is everywhere and Nirakar has no shape, size, or place. But when it interacts with us, then we give a form. Jesus Christ, Prophet Muhammad, or Rama, or Krishna, we use that, some kind of analogy, right? And photonics is the science and application of photons, right? To how to generate photons, how to modulate them, to carry the information, how to detect them, and how to process them. So these are the big process, thing there, right? Also, if photon has no electric charge. So when there's no electric charge, then there's no crosstalk. There's no effect of high voltage. There's no effect of getting electrocuted. There's no, it's safe, right? Photon has no electric charge. And it has no mass also. And it has energy, a lot of energy. And it travels at the speed of light, which is 1,000 times the speed of electrons. So it can travel much faster and unattenuated. So if you want to have, like, you get electric wire, you have to a grid. You see how thick those electric wires are, how expensive it is. But optical fiber is nothing. It's just like a hair. It's one optical fiber. And it can carry the information, large enough to one whole world can talk to another whole world. And doesn't require much energy, because it travels unattenuated. It leaves low carbon footprint. You have lasers, photodiodes, and optical amplifiers, but they all are sophisticated PN junction. So when you are students of electronics, PN junction is most of the devices that are based on PN junction. So study the PN junction properly. Now, electrons and photons, they are natural partners with highly complementary properties. When an electron, change state, a photon is emitted, but when a photon is absorbed, an electron state change. So photon, electron, you can say electron is the father of photons and photon is the father of electrons, or electron is the mother of photon and photon is the mother of electron, right? So they work together. Without, photon without electron cannot work. Electron by itself can work. So photonics depends on electronics. So you really have to pay attention to both photonics and electronics. So the communication is taking place, right? We are having this talk, right? What is happening in that there is a light source, right? This is the laser, it's called, but it has to be driven. You have to apply some electric field. You have to apply bias. That is called electronics, right? So whatever we're talking, this is analog signal. It gets digitized, and you have pulse here. It modulates this laser, and light comes out of optical fiber. It gets detected, but that generates electrical current, and that needs to be amplified. So this is a receiver, this is a transmitter, and this fiber. That's how it works. And the region is going from 700 nanometer to 17 nanometer here. So different wavelengths have different attenuation of optical fiber. But these are the different wavelengths which are used for optical communications. And this wavelength over here, it is used for different other applications, right? So in your today you have your cell phone, iPhone, right? You have 3 cameras there. That uses vertical cavity surface emitting laser for 3D imaging. An array of 30 by 32 pixels. About 1,000 devices are there, right? So this is the area, right? Now, you have to know, because you are building your career, I mentioned that we are in the beginning of the 4th industrial revolution. And when I say industrial revolution, it's the fusion of technologies, for everything smart, right? The technology working together, right? First 3 industrial revolution were when the steam engine was invented. Then second one when steel, phone, mass production started, a light bulb. And third one when the integrated circuit, for your PCs, personal computers, internet, digital age, when that appeared. But now, what are the technologies? That's why you have 8 areas, and that's where you have to build your career. I will not ask you that you work on making lasers or this thing, but if you want to be on the frontier, if you want to build career so that you can strive for rest of your life, you have to think about this. So these are the enabling technologies, right? 4G, 5G wireless today, 6G is coming. You have the broadband wireless access. You have big data and deep learning, machine learning, cloud and data centers and fast processors and sensors, optical interconnects, and software-centric defined system means that everything you work, you change its role through software. Now think about your phone, smartphone. What is smartphone? A smartphone is a software-defined box. Through software, through an app. When you're downloading an app, this means you're downloading software, and you can change its role. Now think about what is a phone. A phone, today's smartphone, it has 5 or 6 radios. Do you know how many radios? What are those radios? It has radio 2G, 3G, 4G, 5G, right? It has GPS, it has Bluetooth, it has GPS, Bluetooth, Wi-Fi. So it has 5, 6 radios, and you don't even know about it, right? It's totally transparent. It changes from, it detects by itself and it reconfigures by itself. So this is software. It can act like calculator, it can be a camera, it can do anything. So that's where it is, the software-centric refined systems network that you have. And India plays a big role in here, right? That everywhere, all the big firms today, they employ a large number of software engineers from India. But these software engineers, they just write software. They do not know how the system works, how the whole thing works. If they know how the whole thing works, then they become CEO. So you should think about that. You get the good background of the hardware, good background software, and the big picture how the system works. Then you could be the CEO of Microsoft, CEO of Google. They are Indians, right? So, and this all leads to artificial intelligence, robotics, drones, virtual reality, augmented reality, autonomous vehicles, and wearables. And everything that matters is connected to everything else. And that leads to smart cities, smart villages, streets, intersection, enterprises. And these, all of them require photonics, right? If you want to access the cloud, you need optical fiber linkage there. Inside the cloud also, there is so much high data rate than the different racks, they are connected with optical fiber. Right, all these companies called Google, Facebook, Amazon, they are building an all global fiber network today because they can't rely on somebody else. So it's just like building your own highway, your own private lines, having your own aeroplane. So these are the kind of area you should be thinking about that you want to build your career, what you want to do, right? So India has done very poorly in materials and devices, but done extremely well in software. So, but you like to go a step further. Think about that, what you could do to fusion of technology. You see, remember the word fusion is extremely important, right? The multiple technologies working together. Single technology is not good enough, right? So today, if you talk about any management person who does the MBA, they teach this curve, right? To exploit the needs of the people to sell their products, right? So the basic needs, your air, water, food, shelter, sleep, sex. Second one, safety, security, love, belongingness, self-esteem, and the higher order needs, right? Self-actualization, vitality, creativity. So these are, but today fundamental need is the broadband connectivity, right? Because if there's no connectivity, you will not be listening to me. I will not be able to talk to you. Right? So this has become the fundamental need today of everyone, right? Even a taxi driver, even a domestic help, everybody needs, right, access. If you don't have access, then you can do nothing, right? So this is extremely important that we have broadband connectivity, and that is based on optical fiber or optical communication. So you need people here, right? And many times you may ask that, oh, my needs are only a few megabits per second. Why do I need a high-speed network? Yeah, you need a high-speed network. It is just like you can say that, hey, I just need one seat. And that seat my bicycle can provide. Why do you need an aircraft which can take a few hundred people in there? Well, it's called latency, and throughput. So latency means when you need a data, how long it takes to reach you, right? So suppose you have a link which provides you 1 megabit data, it will take 8 seconds, right, to download 1 megabit file, right? Download 1 megabyte file. A byte is 8 bits. To download 8 megabit files means you need 8 megabits, right? It will take about 8 seconds if your speed of the link is 1 megabit per second. But it will take only 80 milliseconds if you are transporting it on 100 megabit per second link. So that's why you need a high-speed link. So when these companies, they ask you, hey, what is the data rate you need? 5 megabit per second, 10 megabit per second. So you want to get as high as possible because then your latency will reduce, right? And today India has 99 smart cities they declare, right? And there are 20 smart cities in India already, working. Like you have Kochi here, Coimbatore, at Chennai, right? At least 3 in your neighborhood. And they need here broadband connectivity. There are so many applications, and there's more money in the applications. So, and that's what you can contribute, right? If you say you want to build the transmitter, receiver boxes, you may not be able to do that because of unavailable resources, but you can develop applications, right? You could create applications, and applications bring a lot of money, right? You can do very fast. Just sitting on your computer, a lot of people, I come from BITS Pilani, and in Pilani, there are a lot of startups, the engineers there. They develop the app and they sell it, and they globally. And so you have to think about that, increase the productivity, increase GDP, new jobs, like you have, different companies selling their stuff called this e-commerce, right? I mean, if you're coming from a village, you can set up an app there so that people can sell their kettles. They can sell their goats. They can set up their agriculture products. They can do the bidding, right, in the area. I was visiting my brother who is he works in near Madurai. Is called Bodnakanor. He is in the cardamom business. And he took me to auction centers where cardamom is sold. And it's all computerized. Everything's sold so fast, So you could create many apps, create a lot of applications. That's where money and that's where the jobs are, right? And well, the time is not enough, but the network, that's where the people employ, right? Networks are classified, different kind of, the continents are connected, with the optical fiber. That is called submarine cable network. Then the cities are connected to the optical fiber, like Chennai connected to Cochin, or Kochi connected to Delhi or Bombay. This is called long haul network. And within the city, you have a network, a link, and that is called metro network. And from there, you have a number of these central stations. From here, you have the last mile, there are different homes, offices, or your school. That is called access network, right? And within an enterprise, like your engineering college, inside you may have a network, or big companies may have a network that is called enterprise network, right? Or a company may have multiple offices, Bombay, in Chennai, in Calcutta, and they have their own network, right? It's called a virtual private network, right? You have data centers, right? And you have the cell tower. They also need to be connected to the core network, right? Because you may have a cell tower somewhere here, but it has to connect to the core network, right? So that's called backhaul, front haul. And you have local area network, means that if you are at your home, you have different devices, they are connected together, that's local area network. And if you have personal area network, like you have many peripherals, you have a computer, printer, and other applications, then military have their own network, right? You have avionics when you have a jet fighter, military fighter, jet fighter. It has to have network. It has to communicate to the satellite. It has to connect to the ground control and command centers. Within this thing, it has so many cameras. It has to collect the information. It has to process it. They have to take a fast decisions. If they have to drop a bomb, they need to get instructions. So there is a lot of stuff there. Similarly, on the sea, if you have aircraft carriers, we have submarine. So there is a network there. It's based on optical fiber. You have ground platform. You have sensor network, right? You have the free space optical communication, including underwater communication. So in the communication, you have multiple, needs, and engineers are needed everywhere. And any network, any system is called is called 7 layer, right? In these layers, the top 5 layer, they're all software dependent: application layer, presentation, session, and the bottom 2 are are implemented in hardware. So this is called OSI model. This is called open system interface. So anything is made based on these 7 layers. So when you're studying something, so you should be paying more attention to systems and ask your teacher, hey, which layer we are studying, where do we fit in, why are we studying this? So in the beginning, I told you, ask questions. Figure it out. Where do you fit in? Why are you studying this? What you are studying, right? That would open, your vision, right? That will open, you would have a wide angle to see the world, and you can figure it out. Where do you fit in? What you can contribute, right? And engineers are needed to build and maintain these networks, right, everywhere, right? And the access network, whether you have optical fiber, whether you have wireless, whether you have coaxial cable, or you have your twisted copper wire, they all depends on optical fiber. We don't have time to go through it, but this itself is an area. And India wants to connect all Gram Panchayat everywhere with optical fiber. And once you have it, then you need to create applications. And that would, and I asked Indian universities should set up test bed to train, demonstrate, technologies for smart cities, smart villages, enterprises, home. And this is what your college should do. So you have to ask your management, hey, we'd like to have a test bed. And this test bed you can set up within a week. And it doesn't require much money, because all these devices are very simple and cheap, but it can open up your field, what you can do, because many cities have money, but they don't know what to do, how to implement it. And the money goes back or it gets used up elsewhere, right? So you have to think about it. We can talk it later that you could set up a test bed at your place, which may not cost much, right? But it will help you a great deal. So for the defense, so many applications here, right? In defense. So you probably it will take a lot of time, but in your area, space and defense, there are so many applications that the company will serve optics, space and defense. They had an IPO last week. It was oversubscribed. So it was a company near Bombay. I don't remember the name, but this company, you can think about, the new company came up for serving the space and defense. And you will have to think about that. Talk to them what this company do and how do you fit in there. This is a network like a jet fighter, You have different, the radar and cameras and all that. And you have, a file storage system and different radios. You have vehicle management system and electronic warfare systems, right? So a lot of applications are there, right? You could have, there are a lot of stuff which, in defense, the slides itself is a subject matter of another talk. But the question is that when we talk about industry today, what are their main requirements? The main requirement, the very top most, the cost. So if the product may be there in the market for 100 years, but if you can come out with something which has lower cost, and in addition to that lower cost, more functionality at reduced size, weight, power. That's what the smart power does. Smartphone does. If you have a small device, it has lower weight, it requires very little power, you can charge it and may last for 2 days, 3 days, or 1 day, depending how much your data you use. So these are the things which decide whether you are a winner or loser. So the iPhone today, that company Apple, is the most valuable company in the world. Why? Because they came out with small size, weight, power, more functionality. But for that, people are willing to pay a premium, higher cost. But China is winning in everything because they keep reducing the cost. And other people can't compete. And you need to have whatever you want to have, 24/7 connectivity. All the time connectivity in any form, in any way, the voice, video, data. Large bandwidth and very low latency. And convergence, like the phone does, single smart device, single operator, and all kind of app. Earlier it used to be a circuit switch network, we have packet switch network. We digitize the information and then send them as packet with putting the address of the sender and the address of the receiver, right? It requires heavy digital processing. So you need to study in your school digital processing, quality of experience, right? So oftentimes when you buy anything, you will see that, it's easy to use. That's more important. People are willing to pay more if you can make things which are easy to use. Means you want to have innovations with friendly human interfaces. Design, development, manufacturing, and marketing across the globe, short sort of product development and lifetime cycle, and software-defined systems and network function virtualization. These are different areas in photonics. You can think about where do you fit in. One is the photosynthesis to clean air and beautify your surroundings. Energy, you have photovoltaics, like a solar system. Communication information technology, we have been discussing. Sensing and imaging, that is cameras at different wavelengths. You have lighting, displays, right? You have smart healthcare for diagnostic therapies, gene modifications, and drug development. You have defense security, that is LiDAR, is a vertical cavity surface and emitting lasers. Each smartphone uses about 1,000 of them, and material processing and low-cost manufacturing. So this is very important. I was in Surat, a diamond processing factory, and they now cut the diamond using laser beam, because laser beam diameter is so small, right? There's no mechanical saw, right? If you use a mechanical saw, you will be wasting a lot of material. But laser beam is so sharp, and you can have very sharp, cut. So they use, 400 something wavelength, to cut the diamonds. But the lasers are now used for different applications. The entertainment, you have CD player, DVD player, is all laser beam. For example, my brother, he sort out the cardamom based, the color and sizes. It has so many cameras inside, a lot of optical processing going on, even sorting out these things, right? You have food preservation and sanitization by UV light, ultraviolet light, and agri-photonics, the smart farming, more food for less cost. And these are different areas in optics. Photonics, silicon photonics, linear photonics, neural network, quantum photonics, nanophotonics, nonlinear optics, microwave photonics, terahertz, flexible display, photonics for precision agriculture, artificial intelligence for photonic imaging and sensing, free space optical communications. So an application of, so there are multiple applications, right? So this is for, imaging. That's where defense needs this, right? You use a night vision, right? Night vision camera that you should be able to see, where your eyes can't see. If soldiers in the field, they should be able to see, right? Even raining or you're sitting in the plane. So there are different wavelengths. There are different, this big area. Now, actually, IIT Delhi, I learned that they now offer a degree, BTech degree in imaging. BTech in imaging. It's a big area. Similarly, agriculture, right? So this is another big area. Tons of investment is made in this area, precision agriculture. Right, photonics only helping farmers, food processors, framing, famine-plagued areas of the world. I mean, Kerala is one state, most admired state, because you have all the spices and other things, and you need all the help, right? You have tea there, coffee there, right? So prediction of the protein level, optimum harvesting time, water quality, scheme crops for contaminants, monitor soil health, invasive diseases, irrigation level, fertilizer effectiveness, and precautions where necessary. Predict yield and make better strategic decisions. So think about what interests you, right? And where you can make a difference. Optical technology is also used for soldiers in the battlefield, for everything, because you would like to reduce the weight of a soldier, and you would like to provide soldier 360-degree view. The soldier can see in all directions, right? Because you want to make his hands free. You don't want to have soldier, carrying things in a hand. So you want to put all intelligence in his wearables, so that he can see, take decisions, right? Everything. And India does a lot of import of this. In your case, you could think about this. They make proposal to you, Kerala State Electronics Development Corporation. Go to them if you want to set up your own company. But I'm just exposing you the possibilities. You have to see that this LiDAR, light identification, detection, and ranging, and you can have autonomous vehicles, agriculture, river survey, modeling of the pollution, archaeology, and building construction. So everywhere photonics is playing a big role, right? I told you the healthcare. So you requested me to talk about use of photonics in healthcare. So most of the diagnostic devices, you can take any body part. Photonics is playing a big role, and the market size increasing, right? You can, so many endoscopy, or everything is done. Thermometer is based on photonics today, right? mentioned to you, India, waste billions of dollars of food every year because it got, fungus, and you see that here. If you expose it with UV ultraviolet LEDs, in this wavelength range, so the food can remain like here strawberries, they without and with UV LED exposure for 8 days, you see here get fungus, right? Here nothing happens to that, right? So right, they have mercury lamp. It can change it to based on UV LEDs. The size would reduce here, and it would last for longer. And so this is the big area. India has nothing in there, but if you go to Google and you say the UV sanitizer, you will see that a lot of new products that come out. Right, half of the world fuel is thrown away. So this could be a great area. You could ask yourself, hey, what is important? Hardware, software, firmware, glowware, right? These are the different words, right? Hardware continues to get better, smaller, lighter, and cheaper. And this is a challenge for India. Software getting bigger, more complex and expensive, and this is the big advantage and global opportunity for India. That's what India did extremely well. And the product matures, majority of the cost is software. So today, if you want to have just your smartphone, you may get very cheap, but it's the software operating system inside, which makes a big difference. That's why people go for Apple, whether it's your iPad or whether it's your iPhone, right? The world is moving towards software-defined system, and that's where India had the advantage. So often products fail due to software. So consider as a student having a solid background of both hardware and software, both theoretical and experimental. Unfortunately, experimental part is missing today. So people should be making a case that you like to have a lab, you like to set up something, you like to do something, right? Develop some skill, right? And think big picture, end user and applications, where the product would be used, what would happen to the product, right? Then build product on system engineering and project management if they're available. But if you want to be an entrepreneur, you want to start your own things, right? So you have to think about, take an example of this egg. If the egg cracked from inside, you can get a beautiful bird. But if somebody has to crack it from outside, you just the food of somebody. So you need to have burning desire inside you, So India has today millions of programs and problems, and so are the opportunities, right? And technology only can address them. So invite business, industry, defense, city leaders to learn about their needs and wants. Ask them what are your pain points. Invite somebody from ISRO. Invite somebody from Navy. What are the pain points? How can we help you? So just ask them what is your pain point. What else you like to do that? Look more what society needs and try to invent this, right? Visit expos, find better way of doing existing things. Do brainstorm session in your groups. Come out with ideas. Select a leader on rotation basis. Record minutes. Prepare a quad chart with supporting documents. Your classroom. Provide clarity where none exists and create energy. Need to work under resource constraint space, right? So to summarize, select a right career. Selecting a right career is extremely important, right? If you want to be happy, you want to be healthy, right? It's extremely important. And use IEEE resources for learning, networking, and career selection. Join IEEE if you are not a member, but you don't have to be a member. You have access to IEEE resources through multiple resources, right? IEEE is inclusive. They don't distinguish that you have to be a member in order to take advantage of their resources. Become a volunteer leader. When you join as a volunteer, become a leader, you gain a lot of experience. And photonics has become our lifeline. It is one of the key enabling technology. But it is a multidisciplinary field and has something for everyone. It offers numerous career opportunities. So that's all I have. I just wanted to give you the big overview, but you had to do your own search, right? You had to go. As I mentioned that, see the resources, see your interest, and try to fit your interest and your career goals. That's all, and we can have some discussion.
So some questions have been provided in the chat box.
Oh, chat book there. Okay. Let me see. I don't see the chat book here. Where do I find your chat book? I don't see the. Where is your chat book? It's hidden somewhere here. Where is your chat book? Where do I find? I don't see that. Which option? Yeah, I don't see your chat book. Can you help me with that?
Sir, I will read the questions.
Oh, sir.
Hello?
Hello.
Yeah,
Sir,
I
I
don't
will
see.
read the
Sir,
Okay.
Okay,
Yeah.
sir. So first question, what are the scope of photonics in the engineering field in upcoming times?
Engineering field in the coming?
Upcoming times, scope of photonics in engineering
Well,
field.
that's what my talk was about, right? That photonics, my entire talk was about that, right? I mentioned that photonics is playing a key role in almost everything, right? You see that the very first opening slide, whether it's healthcare, it's agriculture, it is communication, it is, we are at the beginning of the fourth industrial revolution, and there is no field where photonics is not playing a role. So photonics is playing a key role in almost everything. And I mentioned that the photonics is a multidisciplinary field, is an enabling technology. So you will find it everywhere. Like a transistor, so any device, right? You use integrated circuits. So using integrated circuits, you build a system. So similarly, photonics will be incorporated in almost everything to make it faster. Use less energy. So whether you are using the lighting, your LED lighting, or in future, you have the power. So instead of burning the coal, you will see that you are using the solar power and generating the electric energy. So photonics is going to play a vital role in every field. You have to really feel which area you want to be in, whether you want to be healthcare, in agriculture, in communication, in infotech, so in imaging. That's what my entire talk was about.
sir. Sir, next question. What are some of the best universities to pursue a PhD in photonics?
So again, it depends what area you want to work on, right? Each university has has some advantage, disadvantage, and they have expertise in different areas. So you want to work in materials, you want to work in devices, you want to work in systems, so you really have to see. So no university work in everything because field is so big, so large. So it's just like you are going engineering college, you have to see where you want to work in mechanical engineering, your chemical engineering, civil engineering, electrical engineering. So just like that. In the case of photonics, so you may find that some universities are very good in materials, in devices, and some are very good in communication. So again, you have to figure it out what you want to do. But the universities today, in US, they are in photonics. If you go and scan photonics journal, then you will see the papers there. I mentioned in my slide, there are quite a few journals, and you see the papers and the areas, and you will see the university name and the professors there. So you have to do your own research in your area. So if you tell me, you may find that if you are doing communication part, materials part, devices part, the University of California, Santa Barbara, the Stanford, University of Berkeley, California, Berkeley, you have MIT, Illinois, Urbana-Champaign. So there are many universities there, but again, it depends on your area. Each university is good for one area or two areas, but no university is good for everything.
Sir, next question. What are the career opportunities in photovoltaics?
What are for the whole tides? What is the whole tides? What do you mean by whole tides?
Photovoltaics.
Oh, I see. Well, for that, okay, photovoltaics. Well, opportunity are huge in that area because India, this is success story of India, right? India, India needs more and more energy, right? Because everything needs energy today. And because of the pollution, India can't afford to burn coal. And the hydroelectric power also has limited capacity. So India now is working on, like in Kerala, you have installed a floating solar system. So there are many dams and rivers and canals, right? So India has huge scope in this. And this is one area. India has a separate ministry for it. And if you want to win this area, my suggestion would be that you do your master. From IT Delhi, they have a separate department for it, and they have separate courses, and see what are the resources they have. So if anyone, by the way, wants to go for higher studies or want to do something after your undergrad, you should think about doing a master's degree from a good school or IITs, because you'll, open, more scope for you. But photovoltaics is something that is very important, and India has very ambitious program. They would like to generate 100 gigawatt. There's a long way to go. Now Adani's, Ambani's, they are setting up, they are spending, they are committed, billions of dollars to invest in this field. See their press release. They want to set up vertical integrated facilities. They would be making solar cell. Right now, when they make these panels, they import the solar cells. They don't make their own. So they want to build their own. They want to do assembly. So this is one area where government of India is encouraging and providing support and, financially. And Adani, and many others are playing a big role. So what's the next question?
Do GPS system use?
Two GPS system use are what? Two GPS systems use are what? Two GPS systems?
Photonics. GPS
Well,
system.
GPS system doesn't use photonics. GPS system is mostly the RF system, right? GPS. They use 1.6 gigahertz, you have GPS. They don't use photonics there. The only photonics GPS system used is that these companies, they will take photographs, imaging, so that when they're giving you direction, they can also give you photographs, of the place, you want to go anywhere, you want to visit anywhere, so they have the satellite, they can take the photograph. Or the people, they come in their van and they scan the whole area, take photographs and put in the system. So the photonics is used towards the application side. But as far as the communication part is, the link is concerned, that's all RF. Because your GPS system, when it is connected to the satellite, it is connected through RF, radio frequency.
Okay, sir. Thank you.
Any other question?
No, sir.
No, sir.
Okay. Okay, well, thank you very much for inviting me. I hope that you got something out of this call today.
Yes, sir.
Okay, good luck. Bye-bye.
Ninja, please move with the agenda.
Thank you, sir.
Okay.
Now, let me invite some of the participants for feedback. Ms. Anjana Santosh.
Hello. Good evening to all.
Yeah, good evening.
The session was very informative and was helpful. The points you explained was very understandable and it also let us to learn more. I really think that everyone would have got some information from the session and it will help them to get a clarity about their doubts. You also explained about the opportunities in photonics and many areas related to it. We were able to learn a lot today and we are very thankful that you accepted the invitation and came for the session. Thank you.
Okay, well, you're most welcome. You can always
Thank
invite
you,
me back
Anjana.
or
Ms. Srilakshmi Muthu.
Yes. Good evening, sir. The session
good
was
evening.
very clear and understandable. The points explained was extremely helpful, and we were able to understand a lot today. The session was really informative and effective for all of us. I hope everyone who took part in this webinar would definitely got something worthy. And I would like to take this opportunity to thank all the coordinators for taking an initiative to conduct this webinar. And I appreciate the decision for inviting such a prominent person like Naresh Chand sir to take this session. Thank you.
Thank you, Srilakshmi.
Yeah, you all are most welcome.
Next,
Thank you
as
for
a
your
token of
feedback.
gratitude, we are presenting a memento to our chief guest. Devika, please.
Oh, thank you. So nice, so lovely.
Thank you so much, sir, for spending your valuable time for us.
No problem.
So, we have come to the end of our session. Let me invite Ms. Ashika for the vote of thanks. Ashika, please.
Good evening to all. I'm here to present the vote of thanks for today's webinar as we have reached the end of our program. First of all, I would like to thank our Honorable Chief Guest, Dr. Naresh Chand, for spending his valuable time with us. Thank you, sir. I'm sure that today's webinar on career in photonics is going to bring changes and enlightenment to all the active participants of our webinar. I thank the members for evincing interest in covering the event and all the good hearts who worked behind the screen. Last but not the least, I thank my friends for your cooperation on making the function a resounding success. Once again, I thank you all for your attention. Thank you.
Thank you, Ashika.
Thank you, Ashika. The feedback has been hard. Thank you, everyone. Thanks again for joining us today. Thank you, sir.
Okay, bye-bye.